In this video, we're going to do one of the famous wire questions. We have a wire of 10 meters and it's going to be cut into two parts. One part will be used to make a right isosceles triangle, and the other part will be used to make a rectangle where the length and width are in a 2-to-1 ratio. The perimeter will be 10, split between the two. Now we want to know how to split it so that this total area is a minimum, and then also how to split it so the total area is a maximum. Well, we need to figure out what x should be. So there are different options here. Let's let x be there's an isosceles triangle. Let's let x be the length of that side that is represented twice. Okay, so we've got x along both of those sides of the isosceles triangle. Well, that means the hypotenuse is going to be root 2 times x, because the Pythagorean theorem tells us the hypotenuse squared will be equal to x squared plus x squared, so that'll be 2x squared. And then square rooting that, we'll get root 2 times the square root of x squared, which is root 2x. Now, we know that x won't be negative, so we don't have to worry about the absolute value notation. X is referring to a side length. Now, the perimeter of the right isosceles triangle will therefore be x plus root 2 times x, which is ultimately the same as 2 plus root 2 times x. And so we have the perimeter of the isosceles triangle. Well, that means the remaining must be 10 minus this quantity. That will be the perimeter of the rectangle. There's actually a little typo here. That bracket belongs right there. So it's 10 minus the quantity, 2 plus root 2 times x. That's the perimeter of the rectangle. Now, fortunately, they told us that the length and width there are a 2-to-1 ratio. So we're going to let the width be w, we'll let the length be 2w. And so we'll know that the perimeter of the rectangle is actually 6w, w plus 2w plus w plus 2w, meaning that w will actually equal 10 minus the quantity 2 plus root 2 times x over 6. And 2w will equal 2 times that quantity, which can simplify to 10 minus the quantity 2 plus root 2 times x. Again, there's a bracket in a wrong spot there, divided by 3. Okay, so just sort of pay attention. There's been a couple little typos here about where those brackets belong. Okay, so we know what w equals, we know what 2w equals. In other words, we know the length and the width of this rectangle. So we can now consider the domain. Well, it's possible that we use all the wire to build the rectangle. If we did that, then the perimeter of the triangle would be 0, meaning the base and the height would be 0. So it's possible for the minimum value of x to be 0. Well, what would the maximum possible value of x be? That would occur if we used the entire 10 meters to build the triangle and didn't build a rectangle at all. If that was the case, then the perimeter of the triangle would be 2 plus root 2 quantity times x, which we know is equal to 10. So we'd be able to say that x is equal to 10 over 2 plus root 2. That'll be the largest value of x. So we can say 0 is less than or equal to x is less than or equal to 10 over 2 plus root 2. Now, if we're being sticklers about it, we can rationalize that denominator. And the way we'll do that is by multiplying top and bottom by 2 minus the square root of 2. And that will give us a new expression equal to the same thing, but with a rational denominator. So we'll take a moment here to do that. 10 over 2 plus root 2 times 2 minus root 2 over 2 minus root 2. Ultimately, these middle terms in the denominator cancel out. So our denominator is just 4 minus 2, which is 2. So we ultimately get 10 times the quantity 2 minus root 2 all over 2. We can divide top and bottom both by 2, and we get 5 times 2 minus root 2. So we can say that the domain in this question is 0 less than or equal to x less than or equal to 5 minus 2 root 2. You might choose to say, well, 0 less than x less than instead of using equal signs, because maybe you're thinking you can't claim there to be a triangle and a rectangle unless you literally have sum for both. So we'll leave that to your discretion. Now we know that the area of the triangle is 1/2 base times height, and we know the area of the rectangle is length times width. So we know the base and the height of that triangle are both x, so that's relatively straightforward. And we now know what the length and width of the rectangle are. And so what we have here is a great expression for area as a function of x, and we have our domain noted there. Now, there are times where you're going to get an option to round your answer or not, so we'll do a method where we round it and a method where we don't. If you're allowed to round it, then we can change these quantities right here, change them up a little bit, and using decimal approximations and a little bit of simplifying, we ultimately get 1.148x squared minus 3.795x plus 5.5556, and we get we get x is somewhere in the interval between 0 and 2.929. These are all approximations. Setting that derivative equal to 0 would tell us that 2.296x minus 3.795 was approximately equal to 0, because when we take that derivative, the 2 would come in front, multiply the 1.148, reduce this exponent to a 1. The 3.795 would become the derivative of that second term, and then the 5.556 would cancel out. So if we were to use decimal approximations, we would get that x is roughly equal to 1.65. And then at that point, what we would do is determine the total area by plugging in. We have this decimal approximation of the area formula, so we would just plug in a 0 and a 1.65 and a 2.929, and we would get the values shown. If x is equal to 0, the total area is roughly 5.5556. If x is equal to 1.65, the total area is roughly 2.42. And if x is equal to 2.929, the total area is roughly equal to 4.29. So we would say the minimum area would occur when x was roughly equal to 1.65. Now, since the perimeter of the triangle is approximately 3.41x, just in case you're wondering where that came from, recall that we said the perimeter of the triangle is 2 plus root 2 times x. So the decimal approximation of 2 plus root 2 is 3.41. So if we were to say that the x was roughly 1.65, then we would say the perimeter of the triangle was roughly 3.41 times 1.65, which is roughly 5.63. So our minimum area would occur when the wire was cut such that 5.63 meters were used for the triangle and 4.37 meters were used for the rectangle. And the maximum area would occur when x was 0, as we saw on our previous slides. And therefore, that would mean that we made either an infinitesimally small triangle, if you want to think of it that way, or we made no triangle at all, and we used the entire wire to form a rectangle with the given conditions. So that's what it would look like if you were using decimal approximations. If you were doing it a little bit more purely, though, this is well within your powers. What we would do is we would go back to before we did the rounding with our formula. We would get 1/2 times x squared, or in other words, x squared over 2. And then if we distributed the 10 and the 2 root 2 quantity times x into the second bracket and multiplied the 3 with the 16, we would ultimately get this long expression here. We could then collect like terms. We would see that we have, again, there's a bracket in a wrong spot here, so just something to look out for. But this negative 10 times the quantity 2 plus root 2 times x, and this other negative 10 times the quantity 2 plus root 2 times x together would be negative 20 times the quantity 2 plus root 2 times x. And then inside the bracket, multiplying the x squared, we'd have a 4 and a 2. So that would obviously be 6 plus 4 root 2. So all that's going on here is a little bit of collecting like terms. This negative 10 and this negative 10 ultimately make a negative 20 times the quantity 2 plus root 2 times x. So just some elementary collecting of like terms going on there. And since we're adding a couple of fractions, since this fraction here has a denominator of 18, we're going to give this a common denominator. So instead of x squared over 2, we'll call it 9x squared over 18. So putting all of that together, what we see is ultimately we get 9x squared over 18 plus this quantity. And we recognize that 9x squared is a like term with 6 plus 4 root 2 quantity times x squared. So we'll be able to add those coefficients. 9 plus 6 plus 4 root 2 will ultimately be 15 plus 4 root 2. And so, as it's shown in the slide there. And so we can then say that our area as a function of x is given by this formula. Now we can split that apart and we can say it's 15 times the quantity 4 plus root 2 times x squared over 18. And we can split that apart this way. We also have negative 20 times 2 plus root 2 quantity times x over 18. And so we'll express that this way. And then we have this 100 over 18. We express it that way. We do a little bit of simplifying and we get this expression here. We haven't determined a derivative yet. We're still just simplifying the expression. It's always good to clean up before you determine the derivative. Now setting a prime of x equal to 0 means we just take this 2 and we multiply it by this numerator and make the new exponent a 1. We're going to eliminate the x entirely, and then we're going to eliminate the 50 over 9 entirely. And we get this expression here. And then 2 over 18 will simplify to 1 over 9, and that's what we have here. And of course, we just take that negative term, place it on the other side, make it positive. And so multiplying both sides by 9 makes sense because that allows us to get rid of this denominator. And so what we have is 15 plus 4 root 2 quantity times x equaling 10 over 2 plus root 2. Sorry, equaling 10 times the quantity of 2 plus root 2. And dividing both sides by 15 plus 4 root 2 gives us this. Now, it's easy enough to simplify this expression. We don't like having an irrational denominator. So we're going to multiply top and bottom by 15 minus 4 root 2. And when we do that, we get this long denominator right here. And we can do a little bit of simplifying because we have negative 60 root 2 plus 60 root 2, so they cancel. 16 root 4 is the same as 16 times 2, which is going to be 32. So we'll ultimately have 225 minus 32 in the denominator. And so what we ultimately have is an x value of 10 times the quantity 22 plus 7 root 2 all over 193. Again, there's a little bit of simplifying went into there. You might want to go back to the previous slide to see all the algebra again. Now, we're going to do a decimal approximation, even though it won't fit into our final answer. It's just nice to see that that actually fits within the domain. So if we did a couple decimal approximations just for a quick check, we would see that that value actually does fit within our domain. So what we can do then is determine the area if x is equal to 0. And when we plug that into the formula, we get 50 over 9. Not surprised because when we did it with decimal approximations, we had roughly 5.5556. So that's no surprise at all. When we plug in 10 times the quantity 22 plus 7 root 2 all over 193, when we sub that in for x, it's a little more complicated, but not too bad. What we have is just an opportunity to multiply the 15 times this term and the 4 root 2 as well times the exact same term as the 15. And on the other side, we have an opportunity to multiply across those numerators and multiply the denominators. So doing that ultimately gets us to This quantity here in front, 15 plus 4 root 2 over 18 times 58,200 plus 30,800 root 2 all over 37,249. And we're going to subtract this quantity, and we're still going to add the 50 over 9. And doing all that and simplifying a little bit, we ultimately get 2,605,500 minus 694,800 root 2 all over 670,482. Now, truthfully, you can factor out at least 2 from the numerator and denominator and simplify that a little bit, but we didn't do that. That will equal roughly 2.42. If you're wondering why are we using decimal approximations, we're just using that to compare it with the 50 over 9 we got a moment ago for the other x value. And then finally, if we let x be the largest value it could be, which is 5 times 2 minus root 2 quantity, if we did all that, we would ultimately, after a bunch of simplifying, get the quantity 675 minus 450 root 2 all over 9. And again, that quantity roughly equals 4.29. It can actually be reduced as well. The number 9 factors out nicely from the numerator, and obviously from the denominator we can cross those out. But without doing that, we see that we get a value of roughly 4.29, which we had a while ago. And so we're able to say what x value gives us the greatest area, which is an x value of 0, what x value gives us the minimum area, which is an x value of 10 times the quantity 22 plus 7 root 2 all over 193. So when x is equal to that, we know that we have our minimum area. But again, we know that the perimeter of the triangle is 2 plus root 2 times x. So multiplying that quantity by 2 plus root 2, which basically means distributing into the numerator as we know how to do, what we would ultimately get is 10 times 58 plus 36 root 2 over 193. And the perimeter of the rectangle would be 1,350 minus 360 root 2 all over 193. And so to minimize the overall area, we would cut the wire such that we use this many meters for the triangle and this many meters for the rectangle. And we notice that the maximum area will occur when x equals 0, and that's a little more simple to understand. That just means we're going to use all 10 meters to build the rectangle and not build a triangle at all.